Welcome to AWS Direct Connect. Today, we're diving deep into AWS Direct Connect, one of the most powerful networking services AWS offers. This isn't just about creating a connection. It's about understanding how enterprises architect hybrid cloud solutions. Direct Connect is AWS's dedicated network connection service that bypasses the public internet entirely. Think of it as building a private highway between your data center and AWS. We'll start with fundamental concepts, move through architecture patterns, explore real-world examples, and finish with hands-on configuration. By the end, you'll understand exactly when and how to implement Direct Connect in your environment. What problem does Direct Connect solve? Let me start with the fundamental question: what exactly is AWS Direct Connect solving? Imagine you're running critical workloads that need consistent, low-latency connectivity to AWS. Internet connections are unpredictable. Latency varies, bandwidth can be inconsistent, and you're sharing that connection with everyone else. Direct Connect creates a dedicated private connection from your premises directly into AWS's network backbone. This means predictable performance, enhanced security, and often lower costs for high-volume data transfer. The key benefits include bandwidth options from 50 megabits per second to 100 gigabits per second, reduced network costs, increased reliability, and enhanced security through private connectivity. Understanding the physical infrastructure. Here's where many people get confused. Let me break down the physical components step by step. You start with your on-premises router, which connects via a dedicated circuit to a Direct Connect location. These are physical facilities operated by AWS partners, like Equinix or CoreSite. At the Direct Connect location, your equipment connects to AWS equipment via a cross-connect. This is literally an Ethernet cable connecting your router to AWS's router. This creates your Direct Connect connection, which is the foundation. But here's the key. One physical connection can support multiple logical connections, called virtual interfaces or VIFs. Think of VIFs as creating multiple lanes on your highway. Each lane can go to different destinations with different traffic rules. The three types of VIFs explained. This is crucial to understand. AWS offers exactly three types of virtual interfaces, each serving different purposes. Private VIFs connect to your VPCs using private IP addresses. These are your traditional VPC connectivity paths using RFC 1918 addressing. Public VIFs give you direct access to AWS public services like S.3 and DynamoDB without going through the internet. You use public IP addresses, but the traffic never touches the public internet. Transit VIFs are the newest addition, designed specifically for transit gateway connectivity. They support much higher bandwidth, up to 100 Gbps per VIF versus 10 Gbps for private VIFs. The key insight: you can have multiple VIFs of different types on the same physical connection, each with its own VLAN and BGP session. Complete VIF configuration matrix. This slide shows every possible way to configure Direct Connect VIFs. It's comprehensive because there are many paths to achieve connectivity, and choosing the right one depends on your specific requirements. The key insight is that private VIFs can go three different routes: directly to VGW for single VPC, via DX gateway to VGW for cross-account scenarios, or via DX gateway to transit gateway for multi-VPC connectivity. Transit VIFs always connect via DX gateway to transit gateway, but are optimized for this path with higher bandwidth capabilities. Public VIFs bypass VPCs entirely and connect directly to AWS's public service zone. Understanding this matrix helps you make informed architectural decisions based on your bandwidth needs, complexity tolerance, and cost considerations. VGW versus transit gateway architecture. Now, let's tackle one of the most common questions. When should you use a virtual private gateway versus a transit gateway? Virtual private gateway, or VGW, follows a one-to-one model. One VIF connects to one VGW, which then connects to one VPC. It's simple, isolated, and perfect for single VPC scenarios or when you need complete isolation. Transit Gateway, or TGW, follows a hub-and-spoke model. One VIF can connect to the Transit Gateway, which then connects to multiple VPCs. Plus, VPCs can communicate with each other through the Transit Gateway. Here's the modern recommendation. Even for single VPCs, consider using Transit Gateway for future scalability. The cost difference is minimal, but the architectural flexibility is enormous. You can also use both approaches simultaneously. For example, using VGW for production isolation and TGW for non-production environments. Real-world architecture example. Let me walk you through a real-world scenario that illustrates these concepts perfectly. Acme Corp has their main office in Dallas with network 10.100.0.0/16. They need to connect to 3 VPCs. Production 10.200.0.0/16. Staging 10.201.0.0/16, and development 10.202.0.0/16. Their architecture uses 3 VIFs on one physical connection. Private VIF1, VLAN 100 connects exclusively to the production VPC through a VGW for isolation. Private VIF2, VLAN 101, connects to both the staging and development VPCs via Transit Gateway, providing cost efficiency and enabling inter-VPC communication. They also have a public VIF, VLAN 200, for direct S3 and DynamoDB access, bypassing the internet entirely. This hybrid approach gives them production isolation while maintaining cost-effective connectivity for non-production workloads. Cost analysis and optimization. Let's talk money, because direct connect costs can add up quickly if you're not strategic about it. The cost structure has several components. Port fees, the big one, VIF fees, smaller but they add up, and data transfer charges. The port fee is constant whether you use 1% or 100% of the bandwidth. Here's the optimization strategy. Right-size your port capacity, consolidate VIFs where possible, and use Transit Gateway to share connectivity across multiple VPCs instead of creating separate VIFs for each. For data transfer, remember that inbound to AWS is free, but outbound has charges. Direct Connect often becomes cost-effective compared to internet transfer at around 1 terabyte per month. The key is to model your specific usage patterns and compare total costs, not just the connection fees. Multiple VIF use cases. This is where Direct Connect really shines. The ability to create multiple logical connections on one physical connection. Environment separation is a common pattern. Production gets its own VIF for isolation, while dev and staging share another VIF for cost efficiency. Cross-region connectivity is another powerful use case. You can have VIFs connecting to transit gateways in different AWS regions, enabling global connectivity through a single Direct Connect location. Bandwidth aggregation works when you have multiple VIFs to the same destination. BGP ECMP, equal cost multipath, automatically load balances traffic across the VIFs. The key is planning your VLAN allocation carefully and maintaining clear documentation of which VIF serves which purpose. Decision matrix for architecture choices. This decision matrix summarizes the key factors to consider when designing your Direct Connect architecture. For single VPC scenarios, VGW is simpler, but Transit Gateway provides future flexibility. I generally recommend Transit Gateway unless simplicity is paramount. For multiple VPCs, Transit Gateway is almost always the right choice. It scales better and enables VPC to VPC communication. High bandwidth requirements favor transit VIFs, which support 100 gigabits per second per VIF versus 10 gigabits per second for private VIFs. Cross-region connectivity works best with Transit Gateway and TGW peering for global architectures. Cost considerations should include not just Direct Connect fees, but also management complexity and future scaling needs. Now let's get hands-on with the actual configuration, starting with Transit Gateway because it's the foundation of modern Direct Connect architectures. The Transit Gateway creation is straightforward, but the parameters matter. Default route table association and default route table propagation settings control automatic routing behavior. For production environments, I often recommend disabling automatic behavior and managing route tables manually for better control and security. Auto-accept shared attachments is crucial for cross-account scenarios, but should be used carefully in production. Each VPC attachment requires at least one subnet per AZ for high availability. Choose private subnets that can reach your workloads. Direct Connect Gateway Configuration. The Direct Connect Gateway is your central routing hub. Think of it as a traffic director that decides where packets go based on their destination. When creating the association with Transit Gateway, the allowed prefixes parameter is critical. This controls which routes can be advertised from AWS to your on-premises network. Be specific with these prefixes for security. Don't just allow 0.0.0.0/0 unless you really need to advertise everything. The association proposal process allows for cross-account scenarios where the Direct Connect Gateway and Transit Gateway are in different accounts. Remember that Direct Connect Gateway itself is free. You only pay for the VIFs and data transfer. Virtual Interface Creation Details. Now we're creating the actual VIF. This is where the magic happens. Each parameter here has implications for your network design. The VLAN ID must be unique per connection. I recommend maintaining a VLAN plan document to avoid conflicts as you scale. For the ASN, you can use private ASNs 64512, 65534 for most scenarios. Only use public ASNs if you're doing internet routing or have specific requirements. The BGP authentication key is optional but highly recommended for production. Use a strong, unique key per VIF. For IP addressing, you have /30 or /31 options. /31 saves IP addresses and is fine for point-to-point links. Just ensure your equipment supports it. The Direct Connect Gateway ID parameter connects this VIF to your routing infrastructure. Let's take a deep dive into Transit VIF versus Private VIF. This is a common source of confusion that I want to definitively clear up. Both Transit VIF and Private VIF require a Direct Connect Gateway for transit gateway connectivity. The difference is in optimization and bandwidth capabilities. Transit VIFs are specifically designed for transit gateway connections and support up to 100 gigabits per second per VIF. Private VIFs are limited to 10 gigabits per second, but are more versatile in their connection options. For new deployments targeting transit gateway, I recommend Transit VIFs for the bandwidth advantage. For existing deployments or when you need VGW connectivity, Private VIFs remain the choice. You can run both types simultaneously on the same connection for different purposes. Customer Router BGP Configuration. The configuration on the customer's side is often where many implementations fail. Let me show you a production-ready Cisco configuration. The sub-interface configuration creates the VLAN separation. Each VIF receives its own sub-interface with the corresponding VLAN encapsulation. BGP configuration is critical. Notice the authentication key matches what we configured on the AWS side. The timers are more aggressive than the AWS defaults, allowing for faster convergence. Prefix lists are essential for security. Never advertise or accept routes without proper filtering. The ADVERTISETO AWS list controls the routes you send to AWS, while the ACCEPTFROM AWS list controls the routes you accept. Soft reconfiguration inbound is crucial for troubleshooting. It lets you see what routes you're receiving before filters are applied. Advanced routing configuration. Transit gateway routing is where you gain fine-grained control over traffic flow. While the default route table works for simple scenarios, production environments often require custom route tables. Let's compare route propagation versus static routes. Propagation is dynamic and automatically updates when VPCs are added, while static routes provide explicit control. Route table associations control which attachments use which route table. This enables micro-segmentation and security policies. The route selection process follows a specific hierarchy. Static routes always take precedence, followed by BGP routes with the shortest AS path, and then considering local preference and MED attributes. Understanding this hierarchy is crucial for designing predictable routing behavior. Comprehensive troubleshooting approach. When things go wrong with Direct Connect, Systematic troubleshooting is essential. Let me walk you through the process I use. Start with the physical layer. Verify the connection state and BGP peer status. If BGP isn't establishing, check VLAN configuration, IP addresses, ASN, and authentication keys. If BGP is up but routes aren't propagating, check the allowed prefixes in your Direct Connect gateway association. This is a common gotcha. For connectivity issues where you can ping the AWS side IP but not VPC resources, check VPC route tables, security groups, and NACLs. Remember that return path routing must work too. Use the Search Transit Gateway Routes command to verify routes are in the Transit Gateway route table with the correct next hop. Monitoring and performance optimization. Proper monitoring is essential for maintaining a healthy AWS Direct Connect environment. AWS provides several key metrics through CloudWatch. Metrics such as connection BPS egress and ingress show your bandwidth utilization. If you are consistently hitting 80% of capacity, it is time to plan for an upgrade. The metric connection CRC error count indicates physical layer issues. Any non-zero value should trigger investigation with your carrier or AWS Direct Connect location. VPC flow logs are invaluable for troubleshooting connectivity issues. Enable them on your VPCs to see exactly where packets are being dropped. For performance optimization, consider MTU settings. AWS supports up to a 9,000 byte MTU on Direct Connect, which can significantly improve performance for large data transfers. Security best practices. Security with Direct Connect requires a defense in-depth approach. Don't assume that a private connection is automatically secure. BGP authentication is your first line of defense. Always use MD5 authentication keys on BGP sessions. Route filtering is critical. Never accept or advertise routes without proper prefix lists. Be as specific as possible with allowed prefixes. Network segmentation through security groups and NACLs should still be applied even with Direct Connect. The connection is private, but it's still a network boundary. Consider encryption for sensitive data, even over Direct Connect. The connection is private but not encrypted by default. Regular security reviews should include analyzing route advertisements and ensuring only intended networks can communicate. Key takeaways and best practices. Let me leave you with the essential points that will guide your Direct Connect implementations. First, understand that one physical connection supports multiple logical VIFs, each with its own purpose and configuration. Second, Transit Gateway is the modern approach for scalable connectivity, even for single VPCs, due to its flexibility and future-proofing. Third, cost optimization comes from right-sizing ports, consolidating VIFs where appropriate, and careful planning of data transfer patterns. Fourth, security requires active management. BGP authentication, route filtering, and network segmentation are all essential. Finally, proper monitoring and troubleshooting procedures are crucial for maintaining a reliable connection. Direct Connect is a powerful tool for hybrid cloud architectures, but success requires understanding these fundamentals and applying them thoughtfully to your specific requirements.